This is a pressure-temperature relationship problem. A sample of hydrogen gas at 760 millimeter mercury and 20 degrees Celsius is heated to 300 degrees Celsius in a container of constant volume. What is the final pressure of the sample? All right, so in this problem, we'll see that we have, again, a two-state problem because we have an initial condition and we have a final condition. And the change here is that our gas, which is in a container of a fixed volume, constant volume, is heated up. So that's the change. So we have the initial condition and the final condition. And the amount of gas and the volume of the gas is held constant. And so what we know is that there's a relationship between pressure and temperature, and it's a direct relationship. If you increase the temperature, you will increase the pressure. And it's a linear relationship, something like this. Oh, it's too crowded. Let's write it down here. If we have a graph, and this is absolute temperature, and this would be 0, and this is pressure, we have a relationship like this. So as one goes up, the other goes up, as long as the volume and number of gas moles are held constant. So to work this problem, you can think about the ideal gas law. And we know that the gas is going to be, or the number of moles is constant. The gas constant is, of course, constant, and the volume is constant. Rearranging, we get the relationship P over T equals NR over V, which is all constant. So all along this line, our P-T relationship is going to be a constant. And so we can say, well, at the beginning condition, P1 over T1 is equal to the constant, and the end condition as well. So we can use this equation to solve this pressure-temperature relationship. And that is that the initial conditions are equal to P2 over T2. And from this problem, our initial pressure is 20 atmospheres. Our initial temperature is 10 degrees Celsius. Now, this relationship is only linear if we use the absolute scale, so we'll have to add 273 to that to get 283 Kelvin. And then, whoops, that's a Kelvin. And then the final temperature is 30 degrees Celsius, but we'll have to add the 273 to convert to Kelvin, and so that's 303 Kelvin. So plugging these initial and final conditions in and solving for P2, we have P2 is equal to, let's see here, initial pressure, P1 over, so it's going to be P1, okay, so it's going to be times is equal to P1, which is 20 atmosphere, times T2, which is 303 Kelvin, divided by T1, which is 283 Kelvin. And our, units, our Kelvin unit cancels, our atmosphere unit stays with us. So our answer here, when you plug it into the calculator, is 21.4 atmosphere. Okay, and we will recognize that we have 2 sig figs in our temperature measurement, and we will round that to 21 atmosphere for the final pressure.